Hey everybody, today we're back with LetsDefend. We're going to be looking at SOC164 suspicious MSHTA behavior. Inside this alert, we're going to be looking at MSHTA, obviously, PowerShell that's been obfuscated. We're going to look at the EDR. We're going to look at their SIM inside of LetsDefend. We're going to use some external tools like CyberChef. We're going to use VirusTotal. We're going to look at Lolbaz project. So we're going to get deep and down into the weeds on this one to explain how I came to my conclusions on this challenge. This is a challenge I've already completed, but by request, I'm going to go back and revisit it to help the community out. I'm also going to write this up on my blog post, or post this on my blog, so that anyone that doesn't like to watch videos can read through it step by step. Hope you enjoy. So here we are inside the LetsDefend console. I've gone ahead and moved from the closed alerts back to the investigation channel, SOC164, suspicious MSHTA behavior. We're going to go through this one from beginning to end. So looking at what the alert trigger reason was, I'd like to start there. Low reputation HTA file executed via mshta.exe. Okay. The EDR allowed the action. Scary. The command line, we can see mshta called on ps1.hta. And at the binary, we see the binary path, which is the typical path for MSHTA, which is the related binary as well. We see the IP address for Roberto, which is the device there. So, first thoughts. This was my first thoughts going through this. MSHTA, I'm familiar with that from red teaming. ps1.hta was interesting to me originally. PS1 is typically the extension for PowerShell. So if you were to write a PowerShell script, you might use the extension PS1 so that you could call it. And so seeing that as the name of a .hta file led me to believe that we were going to be looking at PowerShell. That ultimately is where we're going to be going with this, as you will see. So let's talk about what MSHTA is. So MSHTA is the Microsoft binary that executes Microsoft HTML applications, so .hta files. Those files are standalone applications that execute using basically the same models and technologies of Internet Explorer, but outside of a browser. So the danger in HTA apps is that they're treated as executable files, meaning that they run basically immediately, just like if you were to click on an .exe file. If you were to double click on a .hta, they would also run, but they'll run if you call mshta.exe and then the HTA file immediately. So that's unlike basically what you would see in a regular HTML application that's being run in the context of a regular browser. What you see inside of a regular browser is HTML that's bound by the security scope of what a browser is allowed to do. So it's confined to communications with like the server, manipulation of the page's object model, reading and writing of cookies. Whereas HTA runs as a fully trusted application on the host, not basically kind of sandboxed inside the browser and only limited by that. What this means is that for an attacker, they can use HTA files to do things like modify system files, change registry values, manipulate potentially running services, things like that. So in my experience, MSHTA files are typically used to run like malicious JavaScript, JScript, VB script to modify system files, registry, or manipulate services, kind of unbeknown to the victim that might be executing it. You would see this maybe inside of a phishing campaign, something like that, where somebody accidentally executes one of these unbeknownst to them. So I have pulled up here the Lolbaz project, the MSHTA file on Lolbaz. So if you're not familiar with Lolbaz, it documents basically all the living off the land binaries that are available to you when you land on a Windows system as an attacker. So if you're looking to do a certain action, you can actually come into the LOLBAS project and basically pick what the action is that you're trying to do, and it will tell you what the binaries that should be available to you on a Windows device are, and how to use them essentially. So if we go to mshta.exe specifically, we can see that we can use it to execute things, use it for alternate data streams, and we can use it to download stuff. It looks like in the context of what the command line argument is here, that we can see someone calls mshta and executes a .hta file. So I believe we're using the execute here. We come down here, we can see that's exactly how you would execute this. You would call mshta from wherever it is on the system, and then the evil file.hta, which in our case is the ps1.hta file. That has this low reputation. So let's go ahead and transition into looking at that. With that, we'll look at it in VirusTotal. So as we can see here in VirusTotal, it's getting red all up and down the board here. Almost half of the vendor engines that are available inside VirusTotal are flagging this as malicious. So it's showing as JavaScript. ps1.text is what it's known as in some situations. IEX commandlet alias, which we will see when we actually analyze the PowerShell. Malware campaigns. So with pretty high degree of confidence, we can say this ps1.hta is probably a bad file. So what would be the next step for that? We've got kind of the idea going here. What direction would I head in next? What direction did I head in when I was doing this? For me, I went ahead and looked at the EDR. So I'm going to hop in here to endpoint security, and I'm going to look for Roberto. The next thing I want to do is look at his command history. So we're going to come in here. We see on this date, so they called PS1, the mshta and the PS1, and then we see a PowerShell command get executed. This PowerShell command is not extremely heavily obfuscated, but it's obfuscated enough that looking at it like this makes it difficult to figure out what it does. So the next thing I want to do is step into this PowerShell a little bit, and let's break that down. Okay, so I've copied over that PowerShell command into Atom, and I have my screen split with CyberChef. Let's go ahead and break down what is happening here on the left-hand side, and as I'm going through it, I'll show you how I leverage CyberChef for this. So I went ahead and broke it down to where you could read reasonably the original PowerShell script, or PowerShell command that was run. So starting at the top, we have a function h1. What that is doing is anytime h1 is being called down here, it is taking this string, which is hexadecimal, and it is converting it back to ASCII text. So basically human readable format. So looking at this, I have no clue what that means. I don't know hex off the top of my head. So if we copy it over here, we see that that is down. Copy this, I'll just keep appending it. That's LO, so down low. And we have ADSTRI in that string, so I'm guessing this is going to be download string, right? Yes. So H3 through H6 ends up being the actual ASCII string download string. So H3 through H6, when they're called inside a function H1, what it's doing is taking the original hex representation of download string that's been broken up into 4 different pieces, and it's reassembling that. H2 here, we have new object, then we have representations like placeholders here. So we have 1, 0, and 2. So in the format here, we have 0, 1, 2. So this is net.webcl IENT. So net.webclient is what this will end up being when it's reassembled after it's been formatted here. Then we have H7, which is taking all of the values from 3 through 6, so that download string, and it's putting it all back together. So as we've called through here, we've taken this from hexadecimal back to ASCII, so we have the download string. We're now putting that all back together so that we actually see not DON, LO, AD, STR, ING, we're seeing download string. Then we're taking H2, so new object, net.webclient, and appending that to H7, which is download string, and then we're appending this to it. So ultimately, what we have, and then we have H8, where we're putting invoke expression. So in PowerShell, IEX stands for invoke expression, which is a commandlet. So ultimately, after you put all that back together, what we have, and I'll blow this up full screen so it's a little bit easier to see, we have invoke expression, new object of .NET web client, which is what that is. So net stands for .NET on Windows. So we're creating a new object of .NET web client. We're going to download this string here, and I have the brackets around this so that it's not actually usable, but it would be just http 193.142.58.23 / server.txt. And so what this is going to do when executed through PowerShell is this has got what is considered a download cradle. So in memory, PowerShell will reach out to this server at this address, and it will request server.txt and then download it in memory. And if that contained something like a PowerShell command, what an attacker could do with that is download the file in memory and execute it without the file ever hitting the disk. That's one use for download cradles. In this case, we're going to find that nothing happens. Next step here, now that we've de-obfuscated this, is that we're going to look at this address, and we're also going to try and figure out what server.txt is. So that's the next portion of this investigation, now that we know what this PowerShell command is doing. Okay, so here we are back inside LetsDefend. Let's go ahead and hop into log management. And in here, we're going to look at that address. So here we are. We found 193.142.58.23. We can see on the date of the offense that coming from Roberto's IP address headed to the destination IP, we have a request for server.txt. Here it looks like we have the response to that as the source and destination have been flipped. We see that we have a 404 not found. Good. So whatever that PowerShell was trying to reach out to do to get that server.txt, nothing came of it. The file wasn't found. The request essentially fails. Now I'll delve a little deeper into why I think that might be. But first, let's look at something else here. Who did this? Why did this get executed? How did this get executed? To do that, we'll hop back into endpoint security, pull Roberto back up. Let's go to processes, actually. Process list. So what we know is that this starts with MSHTA. And in MSHTA, we execute that PowerShell. So if we look at PowerShell, we see that command executed and that the parent process is MSHTA. Good. We already kind of knew all of that. The new information here is that the parent process to mshta.exe is explorer.exe, meaning that the user actually opened this and ran it directly, meaning our user, Roberto, could be an insider threat. Their device could be compromised, and there's something that we're not seeing here, and somebody is has a shell on there and is executing this remotely as a user. It could be, Roberto walked away and the janitor's a hacker and he sat down at Roberto's device and executed this, loaded it up and executed it. We don't really know, but we do know based off the fact that MSHTA started with Explorer.exe that this is a user-driven action. So that's good to know. Is this malicious? Absolutely. 100% malicious. What is the impact? That's the question. With the server.txt being a 404, I think that it would warrant quarantining or containing the machine, because we need to figure out, did Roberto execute this? Did some other insider execute this? Is there another established connection or shell, some sort of persistence on Roberto that we are unaware of that needs to be tracked down? I think that is kind of the next logical step. Based off of what I see, I think it could be a few things. Server.txt being a 404 could indicate to me that the malicious campaign has ended and that the attackers have basically abandoned that infrastructure. That maybe this campaign got out, the user clicked on the link finally after the campaign had already kind of run its course, and that's why we're seeing a 404. Could also be that we're seeing a 404 because this is used as kind of a check-in. It could be that server.txt has never existed and that the attacker is monitoring their logs for requests to capital server.txt and looking for those 404 errors, seeing where they're coming from, and monitoring that as kind of like a command and control check-in. I don't know that that would make a lot of sense, but I guess it could be possible. So at this point, we're going to go ahead and do a case on this and work this through inside the case management. All right, so back inside the investigation channel, I'm going to go ahead and create a case. We're going to start this playbook. Order living off the land binaries. We already figured that out. So we identified the binary. We know it's mshta.exe. Is the current activity suspicious? Yep. What is the suspicious activity? So we know based off of MSHTA and the LOLBAS project that this could be alternate data streams, could be execute, and I don't see the other one. So those are our two only real valid options, and we know it was execute. Who performed the activity? Haha! We went back and we looked. We saw Explorer.exe was the parent process to MSHTA, user. This was not executed by malware. Please go and contain it. Okay, we'll do that. So add artifacts. What can we add here in this playbook to help identify this? What allowed us to come to this conclusion? So the URL for server.txt, where we got the 404, the IP address itself, the MD5 hash, and I think that's it. So 192.168, not 168, is 193.142.58.23. That's just IP. And we're going to add GP 93.142.58.23 server.txt with the capital S. That's the URL address. Hopefully without hopping out of there, I can just get back to what the MD5 was. Did I not look up the MD5? I guess I didn't. So we're gonna have to hop back over here. Hopefully I didn't lose all that. Let's grab this MD5. We're gonna use that as one of the indicators. Back in case management. Yeah, and you gotta go back through this all over again. All right, let's do the MD5 first, since we know what that is. Let's describe that better. MD5 for the es1.hta file. Okay. That's our MD5 hash. Let's get this IP and everything back in here. 3.142, 58.23, / server.text. So that's URL address. And we're just going to do straight up IP. Okay, and looking at these, we don't have an email sender, we don't have an email domain. So in terms of like the challenge for LetsDefend, this is basically like the most bonus points that you could get, right? In terms of adding artifacts. So comments, if you want to go through and explain everything that basically we just did, I would recommend that here. If you're really going through this as an exercise to get better in the SOC, or if you're trying to implement this as something you would do in your own SOC, that's exactly what I would do. Explain this as a case so that somebody else coming back and looking at this knows everything we just did. I'm not going to do that here for brevity, so we'll just see. I'm going to confirm it. Cool. Let's go back to endpoint security. We did say we were going to contain Roberto. So we're going to request containment. Yes. Host contained. Back on monitoring. We're going to close this one out. Close alert. We're going to true positive it. And say we had developed the case notes. Probably just put in here, see case notes. No sense in writing it twice. Alert. You should, if you followed along, have exactly what I have here. You're going to get full points for everything all the way through. We found it was a true positive. We contained the device. We figured out it was the user. We determined all of the suspicious activity and what the binary was, what the purpose of it was, and how it was used. And we've learned a little bit about LOLBAS. The LOLBAS project, or LOLBINs, is what they actually are. So the living off the land binaries. That's it. So at this point, hopefully this was helpful to you. I'm going to also, like I said at the beginning of the video, write this up in a blog post. If for some reason, it's too fast-paced to follow along here in the video, go ahead and check that out. The URL will be in the description below. If you have any questions, please feel free to comment. Like and subscribe. It helps the video channel, the YouTube channel, grow. Reach out to me via LinkedIn or any other social media. I'm Machiavelli everywhere. And I hope this has been helpful. Have a good night.